Hello and welcome. Today we are diving into a concept that's right at the heart of object-oriented programming, the class constructor. You know, if you've ever wondered how your code goes from just a blueprint to an actual working thing, well, you're in the perfect place. Let's get to it.
So we hear this analogy all the time, right? A class is a blueprint, maybe for a car. It spells out what a car has, a model, wheels, an engine, all that stuff. But a blueprint isn't a car. You can't drive it. So what's that magical step? What takes that plan and actually turns it into a real object your program can use?
And that's where the constructor comes in. Think of it like the foreman on an assembly line. The second you say, hey, I need a new object, the constructor jumps into action. It's this special method, and its one and only job is to build that object and get it ready to go. It initializes everything so it starts out in a perfect, predictable state.
Now, this foreman has some very strict rules, non-negotiable. First off, its name has to be exactly the same as the class name. That's how you know it's the right one. Second, its only job is to set up the object. That's it. It's so focused on this, it doesn't even return a value. But here's the most important rule of all. You absolutely cannot create an object without one. It is the mandatory first step for every single object you ever make.
So this brings us to a really important choice that every programmer makes, sometimes without even realizing it. Are you going to let the system handle the setup automatically, or are you going to jump in and customize it yourself?
On one side, we've got the automatic way, what we call an implicit constructor. If you don't bother writing one, the compiler is actually pretty helpful. It just gives you a basic, no-frills one for free. But on the other side, we have the explicit way. This is when you, the programmer, roll up your sleeves and write the constructor yourself. This means you have total control over how your object comes to life.
All right, so once you decide you do want to build your own, you'll find there are a few different specialists for the job. So let's take a quick tour of the different kinds of assembly line foremen you can hire for your classes.
Our first stop is probably the most common one you'll see, the most straightforward type, the default constructor.
Yep, this is your no special orders foreman. It builds the object exactly the same way every single time. It takes 0 parameters, 0 special requests. It just gets the job done according to a standard default plan. And that automatic constructor the compiler gives you, that's a perfect example of a default constructor.
But you know, one size fits all isn't always what you need. What if you want to customize each car as it comes off the line? Well, for that, you need a foreman who can take special orders, and that's the parameterized constructor.
And this right here shows the difference perfectly. See on the left, the default constructor for our car class always sets the model to unknown. You get no say in the matter. But now look to the right. The parameterized constructor takes an argument, in this case, a string called model, and uses whatever you give it to set up the object. This is awesome because it lets you create a new car and tell it what model it is, all in one clean step.
Okay, our next specialist has a very cool, very specific job. What if you don't want to build a new object from scratch? What if you want to create an exact clone of one that already exists?
The process here is actually really slick. So in step 1, we make our first car, C1, and it's a Ferrari. Nice. Now look closely at step 2. That's the copy constructor. Notice its parameter isn't a simple string, it's a whole other car object. So in step 3, when we create our second car, C2, we just pass in our first car, C1. The constructor then takes C1, copies all its details, and boom, a perfect duplicate is born.
All right, our final stop is definitely the most unique of the bunch. This guy isn't about setting up individual objects at all. No, this is about setting up the entire factory before a single car even rolls off the assembly line. The static constructor is a real specialist. Its job is to initialize things that are shared across all objects of the class, the static stuff. You see it's marked with that static keyword. And here's the really weird part. It runs automatically and only once, the very first time the class is ever used, and it never runs again. That's also why it can't take any parameters. The system calls it before you'd ever have a chance to give it any.
So we've met all the different types, but let's just zoom out for a second. Why does all this matter? Why is getting this right so important for writing good, clean code? What's the big takeaway here?
This little cheat sheet really sums it all up nicely. You can see the pattern, right? Almost everything is defined by you, the programmer, and called by you. The two big exceptions, the default constructor, which the compiler can whip up for you if you forget, and the static constructor, which is the only one the system calls all by itself. This is a great little reference to keep in mind.
But really, it all boils down to this. Constructors are your guarantee. They are the gatekeepers that make sure no invalid or half-baked objects can ever exist in your program. By controlling exactly how an object is born, you make sure it starts its life in a state you can trust. And let me tell you, that prevents a ton of bugs down the road.
And that brings us to one last little thought. We've spent all this time talking about how objects are brought into the world. It's this very controlled, very deliberate process. So that kind of begs the question, right? What happens at the other end? What manages the end of an object's life? Something to think about for next time. Thanks so much for joining me.